yeah, so thank you everyone for joining. Good afternoon and welcome back to Machine Learning Live, powered by Amicus Recruitment and the live series. If you're new to the webinar series and do not know who Amicus are, we specialize in recruiting across three key markets within technologies, which include Python, Golang, and JavaScript. Now, my name is Jordan Hayward. I'm a managing consultant here at Amicus Recruitment, and I'll be your host for the next hour. Now, if you tuned in last month, you may remember Eduardo from UnionAI introduce and present their open source tool, Flyte. Well, today I'm joined by Eduardo's colleague and an individual who has previously been a guest speaker on the live series, Niels Bantilan. So today, Niels will be giving us a presentation on UnionAI's other open source tool, a tool called UnionML, which works hand in hand with Flyte. Now, as ever, this session will be interactive and we will be opening up the floor for questions. So if you do have any questions throughout the presentation, do stick them in the Q&A tab at the bottom of your screen, and myself and Niels will get to them throughout. So yeah, that's enough from me. So without further ado, Niels, I'd like to hand over to yourself. Welcome.
Thanks, Jordan. I'm glad to be back here, giving a presentation on another thing I've been working on. So excited to share that.
Good to have you back.
Thanks. First things first. I'll share my screen here. So, as Jordan said, I'm a chief ML engineer. He didn't say that, but I shall introduce myself at UnionAI. And today I'm excited to talk about MLOps frameworks for building and deploying ML microservices. So before jumping in, a little background on myself. My background actually is in biology and dance and in public health. So 3 kind of previous lives before I got into the world of ML and data. Currently one of the Flyte maintainers, creator of Pandera, and the creator of UnionML. And I'd say my mission these days is to make ML and data science practitioners more productive. Anyone that works with data or statistical models. So I'd like to start off with my personal journey through what in sort of retrospect, I think was my journey towards data-centric MLOps. So I'll define what MLOps is in a bit, but I started roughly a decade ago learning Python and R. So I had taken like one comp sci class in college and had sort of dropped it and moved on to other things. So while I was in grad school, I started picking up programming again, and I sort of fell in love with it. So I kind of took it and went with it. I soon learned and dabbled a little bit with JavaScript, and then got my first industry job around 2015. So that was sort of like a data science type of position where, among other things, learned the kind of core data science stack, which does include pandas and scikit-learn. I then moved on to learn other tools like SQL. So some of these you might be familiar with and have used yourself, but you can kind of roughly see that at some point I started moving into distributed computing tools like Dask, PyTorch for training neural networks. Then I moved more into sort of infrastructure, sort of like MLOps type spaces, just to use as tools for my everyday job. So things like SageMaker, DVC. And around 2018-19, I wrote Pandera, which is a data validation tool that I talked about in my previous Python Live talk. And then finally joining the UnionAI team and sort of still doing model training and stuff in my free time, just dabbling around with different models using weights and biases. So these are not all the tools I've used, but you can kind of see the wide variety of this is like a subset of the tools that people are familiar with these days. And in 2022, we launched UnionML, which I'll be talking about. So what is MLOps? It's one of these terms now that have sort of cropped up, and this is a working definition that I like to use. It's the practice and process of deploying and maintaining ML models in production reliably and efficiently. And you can add something about scale and auditability here as well. But basically, you're not deploying like these deterministic, traditional software-based artifacts. You're deploying these models that sometimes are not super easy to understand or interpret, but they are these live artifacts that have been trained on data. One of the problems that you may have encountered while building and deploying machine learning models is that it's very complex. There are a lot of things to think about, and if you were building things from scratch, you could implement sort of you can roll your own solution for a lot of the problems and issues that you might come up with, and oftentimes, we are limited in our scope and our the time that we have. So a lot of times we might roll our own tools and they might not be super maintainable. They might not have the right set of abstractions. But this is a good place to start, and any practitioner should at least understand what the problems are. And one of the solutions to handling the complexity of building ML, which includes handling data, versioning models, deploying those models, is the pipeline. And this is somewhat synonymous with orchestration, where you have a directed acyclic graph, you have nodes, and there are dependencies between these nodes. So this might be data ingest, this might be model training, and this might be a deploy step. And pipelines are great, and orchestrators are great for handling this complexity, breaking up your application into smaller pieces that are more manageable, more easy to maintain. And just to zoom into some of these problems and make them a little bit more concrete, what often happens is there is the research and development part of the machine learning lifecycle, and there's the production phase of it. And obviously that's very simplistic. There's a lot of feedback between those two parts, but that first R&D part is a lot more iterative. You experiment with a lot of things in the lab, and once you're fairly confident or very confident that your model is doing the right thing, you might pick one or two or whatever and deploy that to production. The problem here is code duplication and skew. What I've seen happen in my own experiences with teams is you have, even if it's the same people, you have very different mindsets in these two modes. So when you're experimenting, you're moving fast, you're kind of ad hoc, trying a lot of different models out, a lot of different settings out. You might make ad hoc decisions about how to treat your data, how to process it. And by the end of it, you have some kind of like spaghetti code that has a lot of vestigial stuff from when you were doing your research. And so even if, say I develop these models that I'm happy with, even if I'm the person to put it in production, the kind of things that I want in production, the kind of properties I want in my data processing step, for example, will be very different from the research and development side. Sorry, let me just mute for a second. I'll be right back.
Yeah, no worries.
Sorry, I just need to close up my office door. So that's the first problem, is when there can be multiple duplicate implementations of the same logic, like say data processing logic. And once there's skew, when you go back to the lab, you're going to have your production version of your data processing and then your research version, right? So that's no good. The other problem is that there's recently been a proliferation of data in ML frameworks. So as a team or as an individual practitioner, there are a lot of different choices you can make in which of these tools you want to use, and then how to connect them together, right? And then finally, there's what I call the deployment chasm, which is this chasm where once you have a model that you're fairly confident in and you want to deploy it, there's a lot of stuff that if you haven't had experience with deploying things, there are a lot of considerations and a lot of additional choices that you have to make, which ideally you would have thought about in the beginning of your project. Like, for example, if you deploy a model for some business application, what is the actual KPI that you're tying it to? Not the in-lab kind of loss metric or accuracy metric, but like the conversion rate increase or churn rate decrease, that kind of KPI, where it's very hard to, you sort of have to retrofit your system to incorporate some of these things that you have to think about when you've deployed your model into production. So the central question in this talk and the central question driving UnionML is the question of whether it's possible to define a standard set of methods for machine learning that can be reused across many different contexts, from training to batch or streaming prediction. And this kind of speaks to the code duplication and skew point. And so for inspiration, we can look at web protocols, right? So web protocols have been around for some time now. There are some updates and variations on it, but the main idea is you have a set of verbs or methods like get, post, put, delete, that have well-defined contracts, and the specific implementation might vary from language to language. But this is the nice thing about these kind of interoperable standards is, regardless of the language, you rely on the protocol and to uphold these contracts or to adhere to these contracts, that you can then use Python to call a HTTP endpoint that was written in some other language, and it should all work. And the data exchange formats just work together well. So what does this look like for machine learning? And I don't want to stretch the analogy too far, but this is kind of like the core idea of UnionML. So if we consider a lot of the higher level machine learning frameworks like sklearn, Keras, the ones listed here, we've sort of converged on a few methods, right, or verbs for at least models. So if you look at across all of these five, there's a way to fit a model. There's a way to generate predictions from it. There's a way to evaluate a model on some partition of the data. So I would argue that we're sort of almost there in terms of like these standard set of verbs for modeling. But what about for data? Data is a lot more variable. There are a lot of different, there are a lot of different model architectures as well, but the abstractions, I think, hold across a lot of them. But for data, data from some source, either on disk or external, on the web somewhere. You need to be able to load it into memory, either completely into memory or partially in batches. You want to split that data into train, validation, and test sets, or whatever kind of cross-validation, whatever system you choose to use for evaluating your models. At least for supervised learning, you might want to be able to, if you have a data set, say it's like a SQL table, you want to be able to parse features from targets. You want to transform the data into training and prediction ready formats. So data frames, JSON objects, things like that. And you want to be able to iterate through batches of data in the case of, iterative update algorithms like in deep learning, you use gradient descent and you use mini batches. And then finally, you want to be able to monitor your data for quality and data drift in the lab and also in production. So UnionML is our answer to this, and its mission is to make it really easy to build and deploy machine learning microservices. So just a little bit of a high-level overview of UnionML. It's built on top of Flyte. So Eduardo talked about Flyte. It's an ML and data-aware orchestration tool and platform. And so we're basically piggybacking on a lot of the sort of constructs that make Flyte really robust and scalable and fault-tolerant in production. And we're basically creating a kind of a thin wrapper and set of abstractions on top of Flyte to make it really easy to build and deploy machine learning models. So I don't want to spend too much time on Flyte since we already have a talk about it, but I just wanted to remind you of a few of its key properties which are relevant in UnionML. So you have these things called tasks, right? So these Flyte tasks are the smallest unit of work. You can think of them as like a Python function, say. And you can think of them as containerized functions that have strongly typed input and output boundaries. Tasks are versioned and language independent. Now, workflows are the way you compose multiple tasks together. So you can string different tasks and express the dependencies. And because of the strong typing properties of Flyte, you get a nice property where you can sort of compile your workflows, and Flyte will analyze the pipeline or the DAG that you've constructed. And if, say, this task outputs a data frame and this task input is expecting, say, a list, then Flyte will be able to say, hey, no, these are not, this won't work. Launch plans are ways in Flyte for you to schedule a workflow. So you can say, I want to run this workflow, this training workflow every day at this particular time with a certain set of arguments. It's a static execution graph. So as I mentioned earlier, you can catch bugs at the interface boundary between tasks before even running the code. It's language and framework independent. So since even though the SDK is written in Python, you could have R code in a container task that runs R for a specific algorithm that might only be implemented in that language. And this is a very important one for UnionML, is that you can declare infrastructure requirements in your code. So you can say, set up a Spark cluster, set up a Ray cluster ephemerally in one of the tasks. And I'll skip through this, but it's basically logical groupings of different workflows and tasks. So with all that background in mind, we're basically leveraging all of the core constructs that Flyte offers, as well as all the ecosystem integrations that it has with the various tools in the data and ML space. And the main idea is UnionML is this sort of layer where you can create a UnionML app. It's sort of the source of truth for the behavior of your ML system. And then you can deploy it for various use cases that are required for sort of the entire life cycle of model development. So you can deploy a training microservice on Flyte, a batch prediction microservices service on Flyte, online prediction through Fast API and some other options, streaming prediction, and so that's coming. But the idea is you have a central app that you can sort of deploy to various different targets. So here's a minimal UnionML app. It's a digit classifier. So we're using just an sklearn out-of-the-box data set of digits. So these are literally the pixel values of a I forget what dimensionality image. And the idea behind UnionML is you define your app through a data set and a model. So these are the two like core objects in UnionML. We're saying a few things here that are fairly readable. So we're using a logistic regression model for our model object, and we have a data set that hasn't materialized yet, but we're saying up front what certain things are, like what the test size is, or whether to shuffle the data, or what the target variable is in the data set. Here's the function that reads the data from some external source, but in this case, it's the toy example, so it's just going to call the load digits, the function that grabs the data, I think, that's packaged with sklearn. And then you say what the function is that receives instance of the model object, and then trains it, fits it to some set of features in target. You say how to evaluate your model on some partition of the data, and then how to generate predictions from a set of features. And this is pretty much it. It's maybe like 50 lines of code. And the talk title says it's a MLOps microframework for deploying microservices, right? So the micro here is that UnionML has certain strong opinions about how to structure your app, but you can use any tool that you want. So this is the sklearn digits classification app that I just showed you. This is the PyTorch version, and then this is the Keras version. So this is really designed to be a developer first experience where you can bring your own tools. And really, the guardrails that UnionML provides are meant to be boilerplate and boilerplate savers and sort of productivity enhancers. So you don't have to think about these core methods that you would need to implement anyway for, say, 90% of machine learning applications. So today, as I mentioned earlier, you can then take this app. UnionML handles sort of combining them in various different ways with default implementations for certain things, like the splitter and the parser. And you can deploy training service, batch prediction, online prediction service. Coming soon, we're going to support streaming as well, and model tuning. And in my wish list, which will probably come in a year or so, would be functions for model explainability, visualizing and inspecting your model, and actually getting labeled data from your data set. So just to show you the value of this paradigm, let's take a look at some of these DAGs, right? So under the hood, UnionML is taking the components that you've implemented and assuming certain things, right? Like if you're working with data frames, some of these components I didn't show earlier, but there's the parser and the feature transformer, and the dataset splitter. So these UnionML ships with some of these implemented by default that you can override, obviously. But here's the training DAG, right? It's not too complex, but there are a couple of moving parts. And take note of the boxes in purple. So here's the training DAG. So UnionML basically compiles your DAGs, your components into these DAGs. Here's the batch prediction DAG, right? So all of the components you saw earlier, they're reused here. And here's the online prediction DAG. The only extra one you have to implement is the feature loader. So the main idea here is you can implement all these things once and then reuse them across very different contexts. So in summary, UnionML really like one of its core purposes is it can deploy microservices to various different targets: web, serverless, compute cluster, depending on the use case. So for web endpoints, UnionML supports Fast API. So all you have to do is, you have your data set and model definition. You create a Fast API app object, and you say model.serve app. And that basically injects a bunch of endpoints into the Fast API app where out of the box, it exposes this predict endpoint that you can hit with a curl or a request using the request library. For the serverless endpoint, serverless model serving, UnionML supports AWS Lambda out of the box. So the way this works, it looks very similar. You use Fast API, but then we use Mangum, which is the third-party library that creates a Lambda handler for you. And you say SAM build, SAM deploy. And with very little effort, you've already deployed a model serving serverless endpoint to AWS. You can also create a reactive prediction service. So this is an extension of the AWS Lambda use case where you can configure it to work with S3. So anytime you dump, say, a file containing features, this Lambda handler will kick off. And this is, there's more to this in the UnionML documentation, but basically you can react to these S3 events and then generate predictions in this fashion. So if your application requires this type of use case, where you have an external application dumping files, and then you want a microservice that generates predictions from them, this is one of the options that UnionML offers. And actually, I'm excited to announce a BentoML integration in the 0.2.0 release. So this actually opens up support for various other cloud resource, cloud platforms, right? So with BentoML, you can actually do a very similar thing as the Fast API and the AWS Lambda, like the native integration, and deploy to GCP, AWS, or Azure. Excuse me. The code for this looks very similar. So you import this BentoML service. And because UnionML is opinionated about how everything fits together, we'll actually create the BentoML service automatically for you. And so this is literally the code that you need to set up a BentoML service with the API. And finally, the last thing is a compute cluster target, right? And so this makes sense for model training, model tuning, and batch prediction. And so today we rely on Flyte for handling these kinds of workloads. And so really all you have to do is add some metadata about the remote cluster to your model, say UnionML deploy, and then now you have these basically training and prediction, batch prediction microservices on Flyte. There's a programmatic API as well if you want to do these things from a Python runtime. As I showed you earlier, right, with the integration with Flyte, you can do things like have your dataset reader use a Spark cluster. So say you want to use Spark to do to read the data and do some pre-processing before handing it off to the training task. So UnionML, there's this reader decorator, right, exposes all of the arguments that a Flyte task has access to. So this is the way in Flyte and in UnionML that you ephemerally provision a Spark cluster. And say your trainer uses GPUs, right? You can also control that directly from your app code by requesting the appropriate number of GPUs and memory that you want this trainer to have access to. As you can see here also, these are Flyte arguments. You can basically cache the result of these trainers. So given the same data set, training should just hit the cache and you not have to recompute stuff. Just a quick shameless plug. So with UnionML, you do have to stand up your own Flyte cluster. And so we're working on making that easier and easier. But if you don't want to handle your own Flyte infrastructure, we are working on a Union Cloud product that basically is a managed Flyte cluster. So head over to www.unionai/waitlist if you're interested in checking that out. So in summary, the idea is that we have these and probably other use cases that will crop up in the future. So the streaming isn't mentioned here as well. But the idea is that with a UnionML app, you can sort of like develop your app in the IDE of your choice, use whatever practices you want to version your code and all that good stuff, and then deploy these microservices to various different targets. Just very quickly, the kind of the short to medium term roadmap for this project is there are a lot of different concerns in the MLOps stack. So experiment tracking, data annotation, tuning, feature engineering, feature stores, basically, model serving and data quality and model monitoring. So the idea is that UnionML will integrate with other tools in the ecosystem and not sort of try to creep its scope outside of sort of the core idea of machine learning systems as apps instead of pipelines, and bringing together all the different tools with some certain set of guardrails and guarantees of how these pieces fit together, and relying on this huge exploding ecosystem of different tools to hit some of these concerns, and they're specialized to solve these problems. So UnionML is basically sort of the as the name suggests, the place where all of these things come together. So just to close up a little bit, the whole point, the thing I'm excited about, the whole point behind this project is we want data scientists who want to ship their models to not be so scared or concerned about when they have to deploy these models. With UnionML, you can sort of write a few lines of code, invoke a few command line things, and then you're sort of off to your V0 of your production model. And also at the same time, for MLOps engineers, we sort of want to help them sort of make their time easier. And so if a data scientist needs more GPUs, that they can do it themselves and update their app configuration instead of sort of bothering an MLOps engineer who's already super busy, and make their lives easier. And so I'll end with a meme. We all know this one, basically, which is testing in production. One meme that I really want to popularize is, I want a world where I don't always push to production, but when I do, it's already there. And that's the end of my presentation. If you're interested at all in contributing to this fairly new project, you can try it out with the pip install UnionML. You can initialize a little boilerplate app with UnionML in it, my app. You can check out the repo here on this GitHub link. And thank you. I hope you learned something.
Perfect. Thank you for that, Niels. There isn't any questions in the Q&A tab, so that's just a sign of you mastering the presentation and covering everything, I always think. So thank you so much for taking the time to yet again present for us. I know you've had a busy year of talking at conferences, giving talks on webinars and presentations. So I'm sure you're looking forward to a bit of a break from it all, aren't you?
Yeah, for sure.
Yeah.
Looking forward to sort of like doubling down on building.
Yeah.
And then, coming out from under the rock after I have something more to show.
Yeah. Perfect. Well, no, again, really do appreciate you taking the time to present today, and not just today, previously, and obviously Eduardo on Flyte as well. It's been really interesting seeing what you guys at Union AI have been building over the past few months, and I'm sure a lot of people will be using these tools as part of their kit moving forward. So, yeah, thanks again, and yeah, hopefully in 2023 we have you back at some point, and to those of you that attended today, thank you again so much for attending. If you have enjoyed the live series webinars, not just this one, but throughout this year as well, please do subscribe to our YouTube channel and also follow us on LinkedIn at the live series and also Amicus Recruitment, and you'll be informed of further webinars from there throughout the rest of this year, but also into next as well. But again, thank you so much again today, Niels. Really appreciate your time, and have a great rest of the day and have a great rest of the year.
Thanks, Jordan. You too.
Perfect, Niels. Thank
Bye.
you. Cheers, everyone.